Okay. Okay. Good evening, everyone. So I got message from Venkat. He's not joining due to some family function, and we know this is going to join late, so we can start. Right. So today we will finish off the semi-structured data loading and how to convert semi-structured to structured format, and that will finish our data loading part. The next week we will cover Snowpipe. So yeah, data loading will be covered entirely once Snowpipe is covered, and then we'll move on to the other topics. So you can say 60% or 70% of the course would be finished by then. And yeah, so yesterday we covered the lateral flatten function and how to load semi-structured data into Snowflake through that variant column. So today what we'll do is I'll load the file again and I will convert it into structured format. So that is what we are going to finish off today. So yesterday we created this table called EMP raw, and so I'll load it into the same table. Raw. Okay. Right. Okay. So let's quickly read about this lateral function. So yesterday I have anyway told you how it works. So I'll just read it quickly. Unfortunately, it is not possible to dynamically retrieve all objects in an array with colon and bracket notation alone. Okay. This is where flattening comes in. Flattening is a term for unpackaging the semi-structured data into a columnar format by converting arrays into different rows of data, right? So that is what we saw yesterday. We put some values into an array, and from there we flattened it. So basically what flattening does for arrays is it converts it into rows for the different array elements. The most up-to-date information on flattening can be found in this documentation. In our case, we execute flatten as part of our from clause using the function lateral flatten. The input for the function is the array in the JSON structure. So always the input to a lateral flatten function would be a JSON structure or an array basically. Okay, and this is a table function. Okay, so table function is never written as select lateral function. It is always in the from clause. So yesterday, I think Shiva was trying to do select lateral function something. So I can understand from where you are coming. You can always have some functions in the select query also, like select sum, select average and all that. But this kind of functions, which are table functions, they have to be written at the from clause. Okay, we cannot write it in the column where we write columns, because they basically return table outputs. That is why they're called as table functions also. So the input for function is the array in the JSON structure. It is crucial that flatten is given an alias. There are several fields output by the lateral function. However, we only are interested in the value. Okay. So we will deconstruct this whole thing using that lateral function and dot notation. So this is our JSON format. Okay. And let's look at how to deconstruct it. This is my EMP raw table, and This is my EMP details. Okay. I think this is some other file. No, this one. EMP. Details. Just a second, right? Let me have a look quickly. Detail. Raw. Raw. EMP details. This one. Yeah. So let me take this out in other window. No, I have the JSON open already. Okay. Yeah. So see what. So what we have to do is, I just converted this in the semi-structured to structured format. Correct. So I can give this aliases also, these names. I will give that in some time. But before that, I will explain to you. So what we did was basically, we, as you know, in the lateral flatten, we pass a JSON array. Okay. So for this particular JSON file, our JSON array starts with, if you talk about the outer array, it starts with EMP details here, right? This is the very first one, correct? So we are basically flattening the array of EMP details, whatever is inside that. So inside that, we have three employees. Correct. So if I'll quickly open the JSON parser also side by side. So yesterday, like same thing we did for the lateral flatten. There was a project column which we flattened and it converted into that multiple rows depending on the number of array elements it was having. So we had two array elements yesterday. So in this particular JSON, if you look at the outermost array or the outermost, what happened to this? This is not the one. Sorry. This is the one we are loading. Yeah. So if you look at this, if this is the outermost array and it has inside it, it has got for the EMP details, it has got 3 elements, right? So that is why when I did the flattening there, I did the flattening here. I joined with the EMP table, EMP raw table. I did the flattening and I passed this particular object, JSON object, EMP details. So if I look at EMP details, it has got, if I flatten it, it has got 3 arrays, EMP details, right? So that is why I got 3 rows. And how to extract the values from the JSON objects. For example, these are my key. We know that JSON objects, they have a key value pair notation, right? So this is the left hand side is the key and the right side is the actual value, and they are separated by a dot in between. So the way to access is whatever alias you have given here, whatever alias is there, alias name dot value and give the key name, whatever key it is. So if it is person, it will display person. If it is full name, it will display the name and so on. Okay, so this is how you do it. And if you look at the phone number, it has got area code and number. So phone number is a key, but inside it again there is a JSON object which has more key value pairs. So you further go with one more dot notation and give the key again. So there's a key here again and there's a key again here, right? So that is how you can extract the values. This is called as dot notation, using the dot notation. Okay, giving the colons. So the alias name of the column, whatever in the lateral function that you give here, whatever alias you give here, dot value, and you will get the desired extraction of the values from that particular key. So this is how you can extract it. So now if we look at this children, see all these are having single values. This kind is having one value, full name is having one value. This phone number is also, it is not an array. It is a single value only, but it is a JSON object. Okay, it is not an array. Array is always when you have a open brackets. So children is having a open brackets here, right? So if we try to display children here, I'll display children here. So same way, alias name dot value and the path, the key is children. Now if I what is it saying?
Go back to that JSON. Children is not the key, right? Name, gender, age are the key, right?
Yeah, that is the key. But this is the key. This is the key for the entire array here. See, this is also a key. So key, under this key, there are different values here, but they are also JSON objects. This early braces you see, right? They are actually JSON objects. And this particular open brackets is actually array, which means this children has multiple arrays in this, or multiple children in this. And each children has its own attributes like name, gender, age. So the children is the main key, and the name are their individual keys at the individual level.
Okay. Okay.
Okay, so you cannot directly, so see, you have to traverse through a particular path. It's like a
Hmm.
tree. Okay, you cannot, if you want to go to kind, okay, you have to first go to EMP details and then go to kind. You cannot go directly to kind.
Got it. Got it.
Okay, it's like a tree reverse traversal.
Mhm.
Okay, now see, what I did was I traversed to this path from EMP details to children. So if you see here, it is printing one row and it is a JSON object again. Correct? For the first employee, I have two children, this Jane and John. So it is giving me one JSON object of two array elements basically, the Jane and John. For the second employee, it has got three children, I think, Earl, Sam, and Kit. The third employee, he doesn't have any children, so there is null coming in. So now this also has to be flattened, right? This also has to come into a structured format. So what can we do here now? So you know how to do the flattening now, right? You have done the flattening here. You know how to do it. You have to pass the particular path or that particular object for that to get flattened, that array object. So this is my array object now, right? This children. So I will pass the path of children now to the lateral function so that it further breaks down into more rows, multiple rows. So this way. Again, and I will pass this now. This is my path. This is my array, right? If you look at this column is giving me the array object. So I will pass the array object here. I'll show this to you later. Okay. And I will give some alias. You can give any alias I have given as child. So now same. If you want to traverse the individual values of this, you can say child dot value and we will just print say name. Okay, as of now you can print anything, but as of now let's print name. Let me just remove this. It's giving show again. Unexpected. Child dot value. Okay. Sorry, I did not put that comma. Right. See. So John Doe has two children, Jane and John. Mike has three children, Earl, Sam, and Kit. Right. So this is the actual JSON object of the children. There are two children. The John has Jane and John. So we further broke it down or flattened it into two more rows. And for Mike, Mike has got three children, Earl, Sam, and Kit. So that also we had flattened and it converted it into three rows because he has three children. So do you see some issue here in this record when
One
we
employee,
flatten?
right?
Sorry?
One employee is missing, right?
Right, exactly. So for that, there is a function in the lateral function, there is a parameter called as outer true. Okay, so that you have to pass this one, outer equal to true. So
So null record also.
yeah, see now. So now we have got the last employee also and it has got null. There's no children. Okay, so this is a property that you can pass so that null records can also come up.
So the outer true is make sure that even though if it is null in the child
Yeah,
the parent records, whatever the emperor and the imperial will bring. That is what it says, right?
yeah, correct.
Yeah.
Because this is actually a join. Lateral is actually a join. Okay, so it is a direct join. So you have this is kind of a saying that outer join also should be applicable. In outer join, you get the values which are not matching also, right? When you apply the where conditions and when you do the natural joins, you only pick up records which will satisfy the equi condition, like department ID equal to department ID. Only those records will come up. But if you want records that do not match the department ID should also come up, that is when you come up with full outer joins, left outer join, right outer joins, right? So this is the same value, same parameter or same property. So this
Yeah,
is
it is
how,
outer join, left outer join property. Yeah.
yeah. So this is how you can further keep on through the lateral flatten, keep on converting it into your structured format as per you. So let's print all of them here.
Abdul,
Yeah.
now if you see, our entire query is completely denormalized data, right?
Yeah.
So so most of the databases, right, will be normalized form. Is there any way that we can insert into multiple tables? How do we?
Yeah. You will have to design this table accordingly. Okay. For
Yeah.
example, there will be a children's table, there will be a employee table, department table, and accordingly you will have to create your query to insert into so many tables.
Yeah. So in the Snowflake, there is no option to insert into multiple tables, isn't it? Do you have any insert options in the Snowflake which can insert into multiple tables like that? Insert
Yeah.
when like that?
Yeah, it is there. I will have to check in the documentation I have seen, but it is there.
Yeah.
Any SQL that works for any database, right? That is applicable for Snowflake also. So anything that you can do, like you're talking about multi-table insert, it's there. I think Vinod has done.
Yeah.
See, you have this when conditions and all that. Okay, so this is how you can break up or convert semi-structured to structured. Now we can give, so here as you can see, I can give some aliases also as we defined as F. Okay. Okay, one more thing you might have noticed that all these are coming as codes, right? So if you don't want these codes, you have to convert them into some particular data type because these are all coming from the variant data type right now. So if you want to, you just have to give one more double colon notation here and give the data type that you want. So this will remove your quotes. Okay, see, it has removed my quotes now. So for all the others also you can do. So yesterday, Arumugam, you were asking how to do that, how to apply where condition on the JSON data, right? So if you see here, we have firstly converted this into a structured format. Okay. And now I have given this where condition where F name equal to John Doe. So this way you can give your different conditions. So here I gave a alias as F name. Okay. And I just converted it to that full name into varchar 2. So you can do it for all the other ones also. I am not doing for all the ones, but you can do for all of them. You just have to give double colon and the data type that you want to convert to. And then you can apply your where conditions. So is this what you were asking yesterday?
Now you are putting this in the normal tabular data where condition, right? So
Yeah.
what I asked is I want to put the where class in the value of the JSON format itself.
See, JSON format, you mean like this here in the
Yes.
whole record?
Yes.
No, we cannot do that because this is actually a whole text. It is a text for this particular column. It doesn't know if it's a JSON object or XML object. It doesn't matter to the column that is holding this value. It is a simple variant data type. Okay, so you cannot have a direct access to a particular text in this. You have to convert it into a particular tabular format, and then you can do your regular table conditions.
Mm-hmm.
I mean, at least I have not seen that doing in any other database SQL also. So I'm
Okay.
not sure. I think you have done it somewhere, is it? You were telling me something, right? You did for some Parquet or something.
No, I saw that in some of the forum that they have done for the Parquet. So I just wanted to ensure that that is possible for the JSON or not, because both looks like the same way.
Yeah, some the other way both have same structure, JSON and Parquet.
Yeah. So I just wanted to check. That's it. I haven't tried that. I saw
Okay.
in a
Okay. No, you cannot directly access any column. You can access this with the using the dot notation. This ones and through
yeah,
the
the where
lateral
class
column.
also I saw that in the same format, like the column colon this one, then convert that to a data type. So this is how I saw.
Mhm.
Okay,
Yeah.
but I'm not sure.
Okay. Anyway, so now you know how to apply where condition and how to convert these, right?
Abdul,
So
one question, Abdul. So see, for example, in the real time scenario, I'm getting a JSON format from my source team. So is this the only way that I just dump the JSON into a raw data table and then extract that into a normal tabular format using this function? So is this the only way? So I should be putting this select and using this function and convert do and insert that to a normal table.
yes. Either you create a view of this whole select statement, or either you can insert into some other tables.
Okay.
Yes, you have to write these queries to convert them.
Abdul, is there any way we can read it from file directly and insert like this instead of inserting into table directly?
Sorry, what do you mean? From file, I have
Now,
loaded from file only.
yeah, my question is, instead of me loading into a staging table like this and process again,
Mhm.
is there any option that we have directly read from the file and select it?
Okay. Uh, maybe
I think
if you
this some way. Yeah,
maybe if you
right.
remember that during the staging when
Yeah,
we were
that's what I'm
loading,
asking. Staging.
yeah, when we were loading into the stage, that time if you see we could,
Did from Excel, right? CSV data.
yeah, so we had staged the files, and there we had this $1, $2 kind of
Yes,
selection, if you remember,
yes,
right?
yes.
So on that you can do this.
Yeah, I will explore more on that. One more question. This one, Abdul, right? So now the table is only single table, which is called EMP raw. Can you please go back to the previous worksheet that we were? The EMP raw worksheet.
Yeah, this
Yes.
one.
So it is only single table for us, right?
Yes, single table.
So we cannot directly, as I was studying yesterday, we cannot directly get it from using lateral flatten, which means that we whatever that you are showing me, the only way is we also have to select and then inner join, sorry, subquery again with that same table, then only we can get it. That's what you mean to say, right?
Yeah, same table only you have to do, because this is your JSON dump in the EMP raw, and on that only you have to traverse through, you have to flatten it and then convert it.
that technically we are joining the same table again once for the JSON parsing. That is what you are
Yes,
saying.
same table, and for the any number of arrays it will have inside it.
Yeah, it's like we are doing a self join with the same table again.
Yes,
Get
yes.
the JSON data. Yeah, got it.
It is a self join only. And yesterday you were asking, is there any way to parse the JSON, right? I think like whether it is a correct JSON or not. So this is when you're inserting into a JSON table, a JSON column or variant, you can apply this parse JSON function. So if there is any issue while inserting, it will tell you that there is some issue somewhere. Or else, as you see, when I was loading, I had applied a file format to the loading file of the JSON. So there it will also parse it. But if you want to individually select something and insert into a table, you can have a parse JSON function followed by the values of the JSON, whatever you want to enter. So for example, if I want to enter this, let me remove this insert as of now. Select. See, it says JSON misplaced, line 6. So there's some issue somewhere. I think this one. This phone number after this I have not given anything, but is that null? Actually, deliberately I had put some issue in this.
Is it double quote in the told?
Where?
Double quote. Page 42. Page 42, line number 6.
This one.
So the error says that is what it is. 69 position 2.
No, it is giving same error only again. Something I had done here. I don't remember where. Okay, maybe let's try to parse it. Unexpected string in JSON position. Phone number, area code.
Comma is missing.
After phone number, comma is not there, right?
Comma
Number
is
12.
missing. Yeah.
Here.
Comma is missing.
More than one document in the input. Set is labeled. maybe let's make it a simple JSON maybe. It is inserted, but if I do some, create some issue, maybe I'll remove this. Yeah. So this basically what I'm trying to tell you is about this function, this parse JSON. So if you want to, while inserting a particular JSON, you can always add a parse JSON to it. Or anyway, when you are loading through a file, you have to give the file format anyway for Snowflake to understand that the template that I'm loading is a JSON template. So that time also it will parse automatically and give you error. So I think Shiva was asking, like, is there any way of parsing the JSON before inserting? So this is one function that you can do through.
Thanks. Thanks, Abdul.
Yeah, no problem. So I will put these files inside the shared folder. And so there's this whole exercise of loading and semi-structured, structured, etc. It's all there in the data warehousing badge also. So if you maybe start this week from tomorrow, like one hour also, you will be able to recollect all the concepts that we have learned till today. So it will basically reinforce everything again. Okay. So let's come to the next one, that is XML loading. So I am sure all of you have worked on XML, right? Do I need to explain what XML is? Anybody not worked on XML? Okay. So this is the file that we are going to try and load. So see, this is a DEPT department file. Okay, you know that it consists of its tags and all, right? So this is your tag and this is your value, department ID, and the value is this department name, marketing, then employees that fall under the department ID, marketing, all of these. They have multiple addresses, and then again the employee record, the second employee record. Okay, and he also has multiple addresses and so on. So this is basically information of the employees belonging to certain departments. So as you can see, again, a lot of space has been saved here because department also we have mentioned just once, and under the department, we have given all the employees that belong to this department. Similarly, you can have other departments for which other employees will belong. So this is how you don't have to have redundancy in data, that you don't have to mention department against each employee again and again in semi-structured kind of data files. So that is one of the most biggest advantage of space saving, storage space saving and all that. So again, the same way, XML also we will store into a variant column only. So let me create one new table. Although we can do in the same table also, this one also, EMP raw, but we'll use some other table for this. So any doubts? Okay, before moving, any doubts here in this? How to convert it into from semi to structured format? Okay. If you see, we have the cities lived also. Okay, before going to XML, if you see there's a cities lived also here, right? So cities lived is part of EMP details, then you have cities lived. So can you tell me if I want to, so this first person, John, he has lived in how many cities? 2 cities, Seattle and Stockholm, right? So if you want to print that also here, like what all cities they have stayed in. So can you tell me how to write that here? Can you try? I mean, you can just tell me and I will do it. You understood, right? What I'm asking? See, you can have a look at this. Cities lived is one of the arrays.
You can add group by cities limit.
Who is this, Vinod?
Yeah, group by cities live.
No, Vinod, we are trying to convert that into rows.
We are trying to convert that into rows. Okay.
There's a lot of echo from your side. See, okay, let me add one thing here and then maybe you can.
And traverse from there, right? So
Yeah. Tell me.
yeah, add a lateral flatten function for that children cities lived also.
Okay, first let me go to that cities lived. Right? So this is my cities lived.
Mm-hmm.
Correct?
Yes.
Seattle. And now you are saying we have to add a lateral function now.
Mm-hmm. Lateral flatten input empl detail dot value dot is lived.
I'll call it as maybe CL, okay? Okay, so he has got cities. And now if I want to take the exact values, you just have to write CL dot value and the name of the
place.
is place. Seattle, Stockholm, all that. But do you know why it's coming 4 times? It's only 2 cities, right? There are only 2 cities he has lived in, right?
Okay, but if you look at the gender, I have 2 rows, right? Female, male.
How can he be both female?
Hey, what is the name? I see John, Jane as a separate row. Can you go back to that JSON file? Jane and John, yes, 2 children are there. Scroll down. Yeah, see, he has 2 children, right? So obviously we had 2 rows. So for each row, I'm getting 1 Seattle and 1 Stockholm location, right? So I'm getting 4 rows. It's getting multiplied.
Right, because the children are 2. So for initially it split 2 rows. And then now again we are flattening on the 2 rows basically.
Yes.
So that's why we got 4 rows. So if you remove this from between the children stuff, that time you will get 2 rows. Okay. So yeah, anyway, I was going to create a table.
Abdul, can you go back to that previous worksheet?
Yeah.
In the select class, you added place, right? Can you, in the place, just replace that caps PLACE?
There's nothing there.
Yeah, so it's the case sensitive, right?
Yes. whatever is the key inside this, you have to give exactly as it is.
Okay.
Okay. It will not throw any error. It will simply not find that key there. So it will give you a null, basically.
Yeah, this one I noticed yesterday. So it didn't throw me an error when I put caps, but then I when replaced it with the actual key value, it gave me the results.
Okay. Okay. In what? In Snowflake? In
Yes.
Snowflake. Okay. Okay. Fine. So I will create one table now for XML. Okay. So DPT public. Same, we will use variant only. And I will load that department file that I showed you just now. Okay. For this, I have to create one file format. Sorry?
Yeah, I was mentioning this only, the file format.
Yeah, we have to create one my XML. So it has got loaded. Okay, because there are 4 employees in that. If you look at this department, so this employee ID 1, then there is employee 2, 3, and 4. See, this is a different department. Fourth employee ID belongs to department 2, which is sales, okay, and so on. So, have you any of you guys watched Friends? Did you anyone used to watch Friends? There was a famous sitcom, right? That used to come.
Yes, Abdul. Yes, Abdul.
Right. So these are those
The
characters
coffee
only.
shop name is Abdul Pakavan.
Right. So these are those characters only.
This Chandler and Monica, Joey, and all
Chandler
that.
and Monica, Joey, and all that.
Okay. So this is the XML that we loaded into different. So this is a variant column, and further, so this is also in a semi-structured format only, right? So this now we will see how to convert it into a structured format, similar to how we did for JSON. So slightly there's a difference in XML actually. So let's see how what is the exact difference there. Okay. So firstly, XML is extensible markup language that defines a set of rules for ending documents, encoding documents. It was originally based on some history is there. Another markup language developed for standardizing the structure and elements that comprise a document. Since its introduction, XML has grown beyond an initial focus on documents to encompass a wide range of uses, including representation of arbitrary data structures and serving as the base language for communication protocol. So yesterday, as I was mentioning, whenever you do interactions through the request and response between different APIs, is mostly through XML, right? That because of its extensibility, versatility, and usability, it has become one of the most commonly used standards for data interchange on the web. So obviously it consists of tags and elements. So the tags are nothing but these ones in the less than and greater than brackets. And that is the tag. This address is a tag. And whatever the values are there, they are actually the elements of those tags. Okay. So how to get the how to take out the individual elements from the uh, XML. So so Snowflake provides a function called as XML get. Okay, so this is also in the documentation. This is provided by Snowflake. XML. For Parquet, Avro, and ORCL, it is same as JSON, that dot notation, like how we have used. For XML only, there is a specific function that is used for extracting the XML elements.
So the Abdul, the Parquet and other Abro,
Yeah,
we can use the flatten, right?
here also we will use flatten. In this also we have to use flatten, but to extract the value. For example,
Okay,
in
to traverse to the
traverse.
particular value. Yeah.
Yes, correct.
Yes.
In this we use the dot notation. This is called as dot notation, dot value and colon. But in XML, we will do flatten also, but in that we will use XML get function to get the particular element values. Okay, so it takes three arguments: the name of the variant, either the variant column itself or something that evaluates to variant, the name of the tag you're looking for, that is the your department or employee name or whatever, and optional instance number that is used as an index into Excel structure. So the argument dollar returns the elements value. So when you use dollar, it will return the value, and if you use @ it will return you the element's name, the tag name. So let me show you the query. So we'll go step by step. First, we will not do flattening any first. We'll just try to get some values. Let me change this. And this will be, I think, common. So,
It should be C1, right?
yeah, sorry. Okay, so see what we did was we used XML get to see this is another way of getting. There's a get way also. You can do that, but it's not. There are two ways of doing it. There's a get way where you can pass these arguments, and there's just simply XML get also. Uh, so there's just a difference of how you use the dollar notation. Here you just give a comma and a dollar, and here you give a colon and a dollar. So to not confuse you, you will use just one way. Okay. There's no, I mean, it's not mandatory to know the other one also. So here, what it is doing is XML get function, as you saw, it takes arguments of the column, that is the variant type, and the tag name, or the attribute name. And if you want to fetch the value of that particular tag, you have to use dollar. Okay. So here in this particular, if we talk about the first row, so this is how we traversed it. We did XML get, we passed the column. This is the whole column name and this tag name, department ID followed by the dollar. And if you want to convert it into certain data type, you can use double colon. That is the same as how we did for the JSON also. I'll just give some other alias here. So it will, that way also you can do if you don't want to convert it. So I will print this also without conversion. I'll remove this. Okay, so it will give you codes basically. So if you don't want these codes for string values, you can always convert it into some data type. So here they have converted into string, but the method is same, double colon. Double colon always followed by a data type. So basically you are you're basically changing the data type. That is why you use this. But otherwise to fetch the value, that is only till here actually. You use a function called XML get, column name, and the tag that you want to extract the value of. But if you see now, under the department, we have employees also, right? So see, these are single values. Department ID is one, department name is marketing and sales and all that. But under each department, so see how many departments we have: marketing, sales, engineering, and human resources. Let me just remove the other ones. We have 4 departments. So under each department, there are multiple employees, right? So we have this employee. So if I try to print in the same way, okay, let's do the same way. XML get C1, comma. See what we get. We get another XML, right? Because this is kind of an array element, right? Inside the department, there are multiple employees. For example, if you look at the marketing one, so we have this Chandler. Okay, we just have one, but there could be multiple employees here also. So if you look at the other one, we have Monica. Okay, I think under one department, they have given one employee only. But you can have multiple employees in this, and even that particular employee has multiple addresses also. For example, this particular employee has 2 addresses. This Margaret Robbie, it has got 2, for example, CA, California, and again CA only, but some other address. Some Helena Street here and some Main Street here. Okay, so one employee has multiple addresses and one department can also have multiple employees inside it. So in this case, this is kind of an array only, right? So now here we have to flatten it. So anytime when you have an array which doesn't have a direct one-to-one value, department has a one-to-one value, department name has a one-to-one value. But inside it, when you have multiple elements, that is the time when you have to do the flattening. Okay, so now to fetch the employee records, this employee, if you see this particular tag here, it has got under it so many other tags. So directly we cannot go. So if we try to go to EMP ID, here, this is the next step. Lateral flatten, and you're passing the array object of that. So EMP, and this is how you get the values of those individual elements. EMP underscore dpt dot c1 XML Maybe move this. Just look at for one as of now. Marketing. Hmm. So marketing has got 3 employees, is it? Marketing has got Chandler, then Joey, then Ross. Okay, then the other one starts. Okay, so we have what? Chandler, Joey, and Ross. Okay. So see guys, here you could see that if I don't give this condition, right? It gives me 2 more nulls here, 2 more records basically here. It is because inside employees, so if I print it, see, if I print it, it basically, when I'm passing this column here, this total column here, it is basically trying to flatten the departments also. This also, this department ID, department name, because I am passing, because my employee is under DPT, right? So I have to pass this particular outer array to access my inner arrays. Like that's how we did for JSON also, right? So, but in XML case, it's not a key value pair. It has got different tags also. So it is basically trying to flatten DPT ID, DPT name also, and employee also. So for DPT, there is just one value. For DPT name also, there is one value. But for employee, for this particular department, there are 3 values or 3 employees, Chandler and Ross and other one, Joey, right? So it tried to basically flatten DPT ID also and DPT name also, which is why we have to add a where condition like this, so that it doesn't, it doesn't it doesn't flatten this as well. So which is why we said EMP dot value like this one. And that's how it, this is the actual value that we are trying to flatten. And on this only we have added a where condition that only pick up the employee tag related data. That is why this particular condition was required. So what we did was we simply did a same again. We did a flatten, pass the array to it with the same way we did in the JSON. The only way to, the difference is the only way you fetch the values. So you pass this XML get, pass the value of the column or the name of the column, and then employee ID, that whatever tag name is there belonging to the XML, and followed by the dollar notation. So if you give the dollar, it will return back the Chandler, return back the value of the element actually. So if you further go, you have addresses also. So you have multiple addresses for each employee, right? So for example, this Chandler is living in Central Park Avenue as well as later on shifted to Spencer Avenue. So he is living on 3 addresses, one more, 4300, this one. Okay. So if I further drill down on only Chandler, MP underscore Avenue equal to, okay, this is my Chandler record only. So if I want to go to the addresses tag, only this one. So this is part of my emp.value now, right? So if I, so this is how does it come? It comes like this. Addresses will be traversed like what? DPT, employee, and then address, correct? So if you see here, emp dot value, emp dot value, this particular path is nothing but my DPT till employee. So under employee, I have addresses. So emp dot value, if I do a XML get, XML get, and in this, if I write address, so see, I have one more XML inside it now. I have 3 addresses, right? And if you see it in the Snowflake, it will give dollar as the value name when you look at the data, and at the rate as the attribute name. So if you look at this, what it was saying here, the argument dollar returns the elements value and at the rate returns the elements name. So when you store the data in XML, it will show you like this. So basically it is this, it is the street one is your attribute name, which is here. It's denoted by the at the rate. Okay. And this dollar is actually the value, the central parking. That is what it was saying there, right? So, but now we cannot access this directly now because this is also into XML. So what do we need to do further now? We have to further flatten it again. So we have to flatten this particular part again so that it further converts into rows and columns, further more rows. So we have to now again flatten it. So this time what is the array path here? The array path is DPT employee address, correct? So which is coming from this upper EMP actually, EMP dot value. So this is, so I have to pass that as the array object into my lateral function. So I'm passing this here. Fine. So I have split so many records I've got, but it is only 4 addresses or 3 addresses I think Chandler was living on. But here inside address, inside employee, I have so many other tags also, EMP ID, EMP FName. So it is trying to flatten them also, basically. So I have to give a where condition of address here. Now just 3 addresses. And now again, I can individually get the values of these addresses through the XML get function now. So anything for address. XML get, you can give ADDR, this one here, this one, dot value, and you can give the name of the, say, street one maybe. Street one. Let me just comment this out. Right. So see, Central Park Avenue, Spencer, and 430036 Street, whatever. Central Park, Spencer, and 36th Street. And further, for others also, you can give the same tag names. You can provide city, state, and all that in the XML get function, and it will return back to those values. Employee ID. Yeah. So this is the only difference that is in XML. You need to pass the XML get function to extract the values. Otherwise, lateral, flatten, and all that, it remains the same. And the only way to pass is to get the values is through the dollar in XML. While in JSON, it is simply dot notation. Like this, dot notation. Dot value, and then by the colon of the name of the key, and in XML, employee dot value and colon dollar. So with this, we finish the data loading for semi-structured also. So I don't have to give you any assignments for this, guys. If you do data warehousing batch, you will get hell lot of assignments there itself. And on top of that, you will also receive a badge once you complete it. So I think I will again request all of you to please start that data warehousing batch. So all this that we have done till now, right? You will be able to implement there, and we will have assignments also there. Any doubts on this before we wrap up? So I was just doing on the marketing. If I just remove all of this. So I'll get for others as well. This way. Okay. So then you can insert into your own tables. You can have your normalized table created for each pattern, and then you can accordingly insert the data in wherever you want. But the common thing is lateral function, which is used for converting your semi-structured to structured data. So any questions on this? Okay, guys. No. So if no, we'll continue next week. Please, again, I request, please do the data warehousing workshop. If you spend one hour every day, by I
If
think
you spend one hour every day, by I think
so, you should be able to complete it by the end of the week, and you will get a badge also. I think Vinod, you are trying to say something.
Yeah, can you hear me, Abdul?
Yes.
yes.
Yeah, I need some of your assistance in the second batch, last two lessons actually. So,
Yeah.
what time you will be free tomorrow evening?
We can do now if you want.
We can do now if you want.
I am going for a dinner. So
Okay,
that's
okay. Okay, no problem. Tomorrow,
Okay.
same time,
Okay,
8
no problem.
o'clock.
Tomorrow, same time, 8 o'clock.
okay. Because I need to connect to the Azure account, and then I just need some of your help.
Sure, sure. Tomorrow, let's connect at 8 o'clock.
Sure. Tomorrow, let's connect at 8 o'clock.
Okay.
Okay, guys. So we'll wrap up, and I'll see you next week. Have a good day.